So suppose we have three variables x, y, z of type float, and we have three variables of type a, comma b, comma c. So we know that we can have expressions like a equals to b plus c. We can have x equals to y plus z, where in first expression we are adding two integers, and in second expression we are adding two float type variables. But suppose if you have a user defined data types like string s1, s2 and s3, and if you are going to write an expression like s3 equals to s1 plus s2, it won't work. It is because the operator plus the addition operator, it it can be worked on primitive data types, but for a user defined data types like s1, s2, s3, we do not have a meaning for this addition operator, so they will not work for the user defined data types. But in object oriented programming, our objective is to make object oriented programming provide several features so that user defined data types should work like a primitive data type. Now suppose an expression like this. In this case, this is known as a bitwise left shift operator. Which is also valid in C++. Now, you already have used the same expression, same operator like this, where the same left shift operator is acting like a insertion operator. What does it mean? It means that one operator can behave differently in different situations, which is known as operator overloading. Similarly, another example.
Sir, you're on mute.
Sorry. So, okay, let me start from the beginning. So, today's topic is operator overloading. We have primitive data types. Like here, we have three variables of type float. And am I audible now?
Yes, sir.
Okay. So here there are three variables x, y, z, which are of float type, and we have ABC of integer type. You know that we can have an expression like this, where we can write a equals to b plus c, where b and c, these two operands are added and the operator is plus. Similarly here, two float type variables y and z are added and the value is assigned in x. But if you define a user defined data types, like here we have an example of s1, s2 and s3, which are the objects of string class. And now if you write an expression like s3 equals to s1 plus s2, in this case, this operation will not work. Why it will not work? Because plus operator is an addition operator which can work only on a primitive data type. But for user defined data type, we do not know how this plus operator will work. So you require to define it first. The example of ampersand operator. Here a equals to b ampersand c. In this case, the ampersand operator will act as a bitwise AND operator. But if you write another expression like int pointer p ampersand a, in this case, the same ampersand operator will act as an address of operator. That means, okay, in this example, Here we have b equals to a, the operator 1. In this case, the operator is a bitwise left shift operator. The same operator in C++ can also be used as cout operator A, operator B. In this case, it will act as an insertion operator. That means in C++, we can have any operator which can behave differently in different situations. For this example, the same operator cannot be worked similar to primitive data type for user-defined data types. In object-oriented programming, our objective is to define a user-defined data types, the objects, which should behave much like primitive data types. So these are the situations, these are the issues which can be solved by using operator overloading. So the issue is clear to all of you or not? The first issue is to make operators which are currently acting over a primitive data types to also work on user-defined data types. And second is to define operators to behave differently in different situations. Is this clear? If you have any question, you can ask. Do you have any question?
No, sir.
Okay.
No, sir.
Okay. So overloading an operator means programming an operator to work on operands of types it has not yet been designed to operate. Is it clear? So how you can write an operator overloading expressions means how can you overload an operator? So basically operators are overloaded by writing operator overloading functions. What are operator overloading functions? Operator, okay, let me first write the syntax for this. Suppose we have a class, say class name. So the signature, the prototype of operator overloading function would be at first the return type, a keyword operator, OP is the operator, that means the symbol like plus, minus, plus plus, minus minus or any other operators, and then the argument list. So this is the prototype, and definition is return type, then the class name, scope resolution operator, operator function, and here is the body of the function. So you can write operator plus as a function name where you want to overload addition operator. Is this clear? So this is operator overloading function. These functions can be a member functions of any class, or they can be a friend function of that class where you want the object to be used as an operand. That means suppose S1 and S2, which are the object of two string class. So in this case, you can define an operator overloading function for object S1, that means for class string, where in this case, within this string class, you have to define this operator function, where operator overloading function can be a member function or it can be a friend function. So here, this is the example where you are defining operator overloading function as a member function. If it is a friend function, then the prototype would be friend. You know what is friend function? How how a member function is different than a friend function? Can you tell me? Okay, so here, this is the prototype for the operator overloading function, which is a defined as friend function, and here is the definition. Now, we can define this operator overloading function as member function and as a friend function. So, how can they be different? Can you please tell me? Suppose you have a function named as add function. If this add function is a member function, then you can write first object dot add b, which means one object is used to invoke the add function and second object can be passed as argument. In case of a friend function, you must have to pass both the operands, both the objects as arguments. That means a friend function will always take one argument more than a friend function. So similarly, if you are using a member function, then number of arguments will be always lesser than a friend function. Friend function will take one more argument where the implicit object must have to be passed as explicit object. Is this clear?
Yes, sir.
Okay, so let us take one example of a string class. Suppose here we have a class named string. So here we want to define an operator overriding function for addition operation. That means it will concatenate two string objects. Here is the prototype, and the definition would be return type is string, class name is also string, scope resolution operator. This is the operator overriding function for plus operator. So suppose in any function f, we can now declare objects s1, s2, and s3. So if you do not define this overloading function for the operator, this won't work. But since here we have defined, declared, and defined operator plus, so now it will compile. So you can notice that here the operator overloading function has been defined in public portion. Why? This is because the operators will usually be used in its overloaded form within the non-member functions. So here function f is a non-member function. So to utilize this expression, the operator overloading function must be declared in the public section. Now, for the same code, if you want a friend function, then the declaration would be friend string operator plus
Sir, you're again on mute, sir.
I think there's some sort. Is it working? Am I audible?
Yes, sir. Yes, sir, you're audible, sir.
Okay. So here now you can differentiate between these two. In operator overloading function for plus operator, here we have the member function. So in this case, the number of argument is just one, but in this case, number of arguments are two. Is this difference is clear to everyone?
Yes, sir.
So now the next thing is how compiler will interpret the operator overloading functions. So if you write an expression like s3 equals to s1 plus s2, in this case, at first the compiler will interpret this expression as s3 equals to s1 operator plus then s2. So now you can see that if you have defined the operator overloading function as a member function, then this expression will get evaluated because s1 is the first object which is used to invoke the operator plus function. If you have defined operator plus function in the string class, then it will get resolved and the object s2 will be passed as argument and object s1 will be passed as implicit object. But if you haven't defined the object overloading function as main function, then it won't get resolved. In that case, operator will reevaluate, reinterpret this expression as s3 equals to operator plus s1 comma s2. So if you have defined the operator plus function as friend function, then this expression will get resolved. But if you haven't defined the operator overloading function even in friend function and as in member function or as friend function, then the compiler will report an error to the effect that the given operator has not been overloaded for the class. Is this clear? So in that case, my question is that the member function and friend function for the operator overloading will act completely same. For example, for this expression, if you define your operator overloading function as a member function or as a friend function, in both the cases, the same output you will get. So my question is, why should you have two different techniques to define the operator overloading functions? Why you should use friend function instead of member function? Can you tell me? Okay, suppose we have a class A, which you have defined, and you have also defined operator overloading function for plus operator. Suppose A1 and A3 are the objects of class A. Now suppose you have another class, say class B, which has been defined by some other developer, or say a primitive data type, say integer C. So you have an object of class B as B1 and a variable C as integer. Now suppose we have an expression like A3 equals to A1 plus B1. You have defined operator overloading function for class A. So can you tell me whether this expression will get evaluated or not? A1 is the object of class A, but B1 is an object of class B. Or say this expression, whether they will execute or not. Hello, are you getting my point?
Can we explain it once more?
Okay, so here in the my question is that we have operator overloading function which you can define as a member function, and you can also define them as a friend function. Both of them will act completely same. So why we have two different methods? Why, if you can define it as a member function, then what's the need of using friend function as operator overloading function? So to explain that, here we have a class A which is defined by you. You also have defined operator overloading function within class A. A1 and A3 are the objects of class A. Similarly, you have another class B, which is defined by another developer. So you do not have control over class B. Now here we have an expression A3 equals to A1 plus B1, where A3 and A1 are the objects of class A, B1 is the object of class B. In another expression, we have A3 equals to A1 plus 10. So my question is whether these two expressions will get evaluated or not. Will they get executed? Hello. Hello.
Yes, sir.
Look, are you online or not? If you are
Yes,
not,
sir.
if you are not available, then there is no point of doing this all things. I can send you slides also. Isn't so? I am ready to explain you, But if you have any question, you should have your attention. My question is clear to all of you or not?
Yes, sir, it's clear.
Yes, sir.
So can you tell me whether these two expressions will get executed or not? Will there be any error?
So there will be error.
Why?
Sir, we are using two different classes and one class is not friend class of another, so it will not be allowed to have access of private data members.
These are objects. These are not data members.
Sir,
The-
sir,
Hello?
sir,
Hmm?
operator overloading function of plus will be taking argument of class type A and we are providing argument of class B. So it will be a error.
Okay, so that's your point. But since class A is being defined by you, you can have an argument of type class B. For example, suppose for class A, you can define the operator overloading function like this. Sorry. Let's take it like this. A is the return type operator plus B X. Isn't so? So here, sorry. So here you are defining operator overloading function, which will take an argument of type B. Or for second expression, you can have an argument of type integer. Isn't so? So in that case, they will get executed. But suppose you are writing the expression like b1 plus a1 and 10 plus a1. So the compiler will interpret these expressions. In the first case, the expression will be interpreted as a1 dot operator plus b1, which will get resolved by this prototype a1 dot operator plus 10. Yet so they will get resolved. But in this case, it will be interpreted as b1 dot operator plus a1 and here 10 dot operator plus a1. So clearly you haven't defined the operator overloading function in class B1 in class B, so it will not get executed, and for primitive data type this won't work. So if you define your operator overloading function as as a member function, then you will face this type of issue, which can be resolved by using a friend function. So if you use this prototype, then it will take B as the argument, because the interpretation will be A3 equals to B1 plus A1. It will get interpreted first as B1 dot operator plus A1. Clearly you haven't defined, so it will not get executed. Then compiler will reinterpret it as operator plus B1 comma A1. So now in this case, it will get resolved. So is this clear? So that is why if you have an expression which involves two different data types, or one class type variable and another is implicit data type, then in that case you must have to use a friend function. Is it clear?
Yes, sir.
Okay, so let's move to another topic. Why to use operator overloading? So in this example we have used S3 equals to S1 plus S1 plus S2. You know that we can get the same output if you use a normal function like this. S3 equals to S1 dot add S2. You can write this expression which is similar to using this. But in this case, what's the advantage? The advantage is that here the overloading will provide better readability of the code. In primitive data type, in cases of integer, float, character, and like that, we are habituated to use expression like C1 equals to A1 plus B1, where A1, B1, C1 are of type integer. So we can have the same syntax for user-defined data type. So clearly it will make the code more readable. But that's not the only situation, only cases, or the only use where you should use operator overloading. So there are some situations where it is necessary, or say they are mandatory, to use operator overloading functions. For example, suppose the objects of the class which acquire resources dynamically during runtime, and no two objects should share the same copy of the resource. Am I audible?
Yes, sir.
Thank
Yes,
you.
sir.
So suppose we have a string class. We are creating an object S1 with ABC as initial value, and we have another object S2. Now suppose we have an expression like S2 equals to S1. So here you can see that we have two objects which are taking resources dynamically during runtime. Now, if you do not overload this assignment operator, then what will happen? So, like in previous example, we have two data members in the string class, CSTR, which will hold the character dataset, and length is for length of the string. So here 101 is the address where the string ABC is stored. So this is the address, and length is 4. Now when you declare S1 like this, so ABC is stored in a memory with address 101 is allocated, and data members of S1 object is assigned the value 101 and length as 4. Now when you declare S2 and you write this expression S2 equals to S1, then what will happen is that the data member of S2 object, the CSTR, will also copy the same value, because the default assignment operator will copy the values member by member. So it will also have value 101 and length as 4. So both these objects will point to same location. So that means if you manipulate value of string S2, it will also get reflected in the object S1 and vice versa. So that is obviously is not what we want. We want the object S1 and S2 to have two different or two separate memory blocks with same data. That means we want another block of memory, say 201, which will also have the same values. So in this case, overloading this assignment operator will become mandatory, Okay, you if you have studied copy constructor, so in that case, you may have faced the same situation where if you are using default copy constructor, in that case, both these objects S1 and S2 will have the same data members, as same value as data members. Is this clear? Do you have any question over this? This is hello.
Clear, sir.
Okay. Okay. So let's move to another point. Suppose you have the objects of the class which acquire some resources dynamically during runtime, and no two objects should share even different copies of the resources. That means, suppose you have first object as O1 and second object as O2, and you do not want that any of these objects would be allowed to even share separate set of memory. That means, if suppose O1 has ABC, you do not want O2 to have the common data or even separate data. That means, in simple word, you do not allow assignment operation. So in that case, the simple solution is that you will define operator overloading function for assignment operator, and you declare this in the private portion. So since this operator overloading function is declared in the private section, so from non-member function you cannot write these types of expressions. So clearly, assignment operation will get blocked by the compiler. Another situation, it can be suppose the default action of the dynamic memory management operators, that is new and delete. So you know that these two operators are used to allocate memory dynamically and to make dynamically allocated memory free. They have some default behavior and you are not satisfied with that default behavior and you want to change that. So in that case, you can overload these two operators so that you can define your own memory allocation operator and memory deallocation operator. So these are these different situations where the use of operator overloading function will become mandatory. So I think what is operator overloading function and the situations where you should use operator overloading and how to define operator overloading is clear to all of you, isn't it? If you have any query, you can ask. Okay, so there are certain rules to use operator overloading concept. The first one is that you cannot create a new operator. For example, suppose here we are using 2-star operator. You know that 2-star, this kind of operator doesn't exist. So in that case, you are not allowed to create this operator overloading function. That means you cannot create new operators. Second is meaning of existing operator cannot be changed. For example, suppose you know that you can write any operator overloading. You can write operator overloading function for operators. So suppose here you have operator plus and you want this. That means uh, for a primitive data types like int, a and b, you are writing this expression a plus b and you want that this plus symbol will actually subtract the values. That is not possible. So you cannot write an expression like this. How can they be restricted? If you are using operator plus function as member function, so one of the object is passed implicitly. So one of the argument must be an object type. Similarly, for friend function, it will be mandatory to use at least one class type variable. You cannot have both the arguments as primitive data types. One must be a user defined type. Third is some of the existing operators. For example, scope resolution operator, member selection operator, member selection through pointer to member, conditional operator, size of operator, type ID operator. These type of operators cannot be overloaded. Similarly, some operators can be overloaded using non-static member functions only. For example, assignment operator, function operator, subscripting operator, and pointer to member access operator. These are overloaded only using non-static member functions. So suppose a binary plus operator takes two arguments, two operands, then you cannot change that number. You cannot use single operand for plus operator. Similarly, for unary operator, you cannot pass two arguments. And the sixth one is that overloaded operators cannot take default arguments. So these are some of the rules which you must have to follow. Okay, let's take one example of operator overloading function. You know that we have three types of operator: unary operator, binary operator, and ternary operators. You cannot overload ternary operators, so we have left with unary operators and binary operators. So if you are using member function, then unary operator will not take any argument. If you are using as friend function, then it will take one argument. If these are binary operator, then member function will take one argument. and for friend function, it will take 2 arguments. I think this is clear to all of you. Friend function will always take 1 argument more than a member function. In unary operator, the object will be passed implicitly. For binary operator, one object will be passed implicitly and another will be passed as argument. So, suppose we will start with in increment and decrement operators. Suppose, okay, do you remember the distance class? Distance class is a class where there are 2 data members. One is feet, which will take data value as feet, and inches. These are 2 data members, and there are several member functions. So if you write plus plus d1, it will increment the value of the object d1 by 1. Similarly, you can have d1 plus plus. This is postfix operator, and this is prefix operator. Similarly, for decrement, you can have minus minus d1 or d1 minus minus. So in this case, compiler will at first interpret this as, suppose d2 equals to d1. So this will be interpreted as d2 equals to d1 dot operator plus plus, and no argument will be passed if it is a member function. For class distance, it will have 2 data members. In public section, you can write the operator as distance is the return type, operator plus plus. This is the prototype. Rest of the class definition. The definition would be return type as distance, class name is distance, scope resolution operator, operator plus plus, return distance plus plus I fit and f inches. So if you write plus plus d1, then the compiler will interpret this as d1 dot operator plus plus. This operator overloading function will be called. What will get returned? Plus plus I fit. That means feed value of the object d1 will get incremented. F inches will remain same. Okay, can you explain me this statement? Return distance plus plus I fit f inches. This is my last topic. Can you please explain this? Hello. Can you explain this expression? Hello. Okay, so let me explain this thing. So in this case, what happens is that we need to increase the value of feed data member only, and f inches will remain same.
Sir, your screen is not visible.
Sir, your screen is not visible.
It's not visual. Okay. Is it visible now?
No, sir.
No, sir.
Okay. Okay, I don't understand why it's not getting displayed. The last expression was that from within operator plus plus function, we are returning distance within our argument plus plus I feet and f inches. So our objective was plus plus d1. So d1 object will get incremented value. So only I feet data, I feet member will get incremented and inches will remain same. So in this case, what happens is that at first, the ifit data member of the calling object gets incremented because we are returning plus plus ifit. The second is that there was an explicit call to the constructor. We have the statement distance and within bracket plus plus ifit. So this, in this case, we are calling the constructor distance bracket. So that distance constructor, it will create a nameless object of the class distance where two arguments, the incremented value of I feet and f inches will be passed. And then third, the nameless object will be returned from the operator overloading function and the return value will be assigned to D2 object. So it will minimize many of the overheads where you will create a temporary object of type distance, you will increase the values and then you will return. In that case, the value will get copied, so a copy constructor will get called. So there are several overheads which can be reduced if you create a nameless object like the statement I have given you. So in this case, we are using increment operator. Similarly, for a postfix increment operator, the situation will be little different. I will discuss that in next class. For decrement operator, again, the expression will remain same. Instead of plus plus I feet, you will use minus minus I feet. So any question? Okay, so I'll stop at this point. If you have any question or query, you can send me email or message, and in next class I will discuss the remaining things. That means the postfix operator and the examples for binary operator overloading. Is that okay?
Yes, sir. Okay, sir.
Okay. Okay. So now I'm stopping this meeting.